the alternating series test. One thing to keep in mind with the alternating series test, the reason why we call it an alternating series is the numbers will alternate between positive and negative. So an example of an alternating series might be I start out at 1, and then I'll add plus a -2, or really -2, plus 4, -8, plus 16, -32. And the idea with this is it just keeps going positive, negative. So instead of like, typically this one would grow out of control. However, with the alternating series test, since we're always kind of canceling out some area, there's a chance that it could converge. Now, the alternating series test can only tell you convergence. It cannot tell you divergence. So if so just to please, kind of keep that in mind. There's two things with an alternating series test we need to look out for. We need to make sure that it's always a decreasing function, so the next term is always smaller than the previous term. And we also need to show that the limit of that sequence is 0. So when you're kind of taking a look at these, one thing that's usually kind of nice and helpful to do with them is to substitute the values in to try and like expand the series to kind of get that idea of, are the numbers always shrinking? And when you're checking to see if the numbers are always shrinking, we're not actually worrying about the alternating part. Now, one quick thing we didn't talk about yet is how do we know if it's an alternating series? And it's really typically this guy right here. That's -1 to some exponent. That's going to make it go positive, negative as those exponents change from odd to even. So it's kind of like, I would always call this like the bat signal. Hey, this is showing you the alternating series. It's the warning light to say, hey, probably alternating. Let's check this thing out. So again, as we check this alternating series, we're going to first kind of see if it's constantly decreasing. So if I were to expand this alternating series and I'm only looking at the numbers, I know positive, negative is going to change. I'm looking at like just the positive values. So we're going to ignore the -1 to the end part. We'll substitute in 1. So we have 5/2. Then we would have the next term in this sequence would be 5/2 squared, or 5/4. Then it would be 5/2 cubed, 5/8, and so on, right? And 5/16, and this would just continue. Now we are seeing that these numbers are getting smaller over time, so it's meeting that first condition. The second condition we want to look out for is to check to see if the limit is approaching 0. So the limit as n approaches infinity of, again, just the alternating part, not I'm sorry, just the sequence part, not the alternating part. So the limit of 5/2 to the n, we do get 0. So since this meets both criteria, it's getting smaller, right? The function is decreasing. And the limit is 0, we could say that this converges, right? This alternating series converges.